Now it is given in GATE 2014. They are saying that we have 3 processes and 3 resources, and they are given the matrix like this. See, in the question you should be very careful. Sometimes they give that allocation is something, and then they will say that the future demand is so and so, and sometimes they say that allocation is something and the total demand is so and so. So you have to be very careful about it, and there have been various terminologies here. But once you understand the question, the solution will be very simple. This is the simplest question you could see. Okay, watch it now. So they are saying that 3 processes and 3 resources are there, and the resources are allocated to process this way, which means 0, 0, 1, 3, 2, 0 and 2, 1, 1 like this, right? This is allocation, which we have already seen. There is nothing much different here. And next one is maximum. This is nothing but this is the maximum number of resources that every process will require in order to finish its execution, which means if you have to assign 8, 4, 3 so that this P0 will execute. Now the difference between the earlier questions and this one is, from this maximum we should find out the future demand, right? This is the maximum what they wanted, and this is what we have allocated at present. Therefore what will be required in the future? That is what we should compute first. If this is the maximum what they wanted, and if this is what we have already allocated, then in future they will need, you have to subtract this one from this one, right? So 8, 4, 2. Understood this? Because already one resource of Z is allocated. Now if you allocate 2 resources, totally it is going to make up 3. That is the reason. And similarly, if this is the maximum required and if this is already allocated, then what is the future demand here? It is 3, 0, 0, isn't it? 3, 0, 0. And similarly here also, if this is the maximum required and if it is currently allocated, then what is the future required demand? Future demand is 1, 2, 2, isn't it? So from 3, 3, 3 I subtracted 2, 1, 1. So that is the future demand, right? And then they are saying that this is the available matrix. Available means these are still available. I mean, you have 3 more copies of X, 2 more copies of Y, 2 more copies of Z, even after this allocation. Now using this one, you are supposed to satisfy those demands. Now they are saying, if the system is in this state, and they have already declared that the system in this state is safe. We don't know that, but they have already declared it in the question itself. They are saying that the system is safe in this, right? You please read the 2014 question. The system is safe in this, and then they are asking from that state will request 1 be granted and will request 2 be granted, which means they are asking us to find out whether this one can be granted or this one can be granted according to the Banker's algorithm. Okay, anyway we are going to solve it, right? And before that, I just want to verify once whether this state is really safe or not. How do you verify that a state is safe? From that state given, you try to allocate the demands in some order in such a way that all the process can be satisfied, right? So just watch it. Now what is the available here? Availability is 3, 2, 2. Now with this availability, whose demand can be satisfied? We are not talking about the maximum, we are talking about the future demand, right? Whose demand can be satisfied? We can satisfy the demand of, we cannot satisfy P0, we can satisfy P1 as well as we can satisfy P2, anything we can satisfy. Therefore let me satisfy P1. If I satisfy P1, then what is that it will release? It is going to release 3, 2, 0, right? And now I'll get 6, 4, 2, right? Now with this availability 6, 4, 2, what can I satisfy? Obviously P0 cannot be satisfied, then P2 can be satisfied. If I satisfy P2 need, then what will be, what will it release? It will release 2, 1, 1. Therefore what will be the new availability? 8, 5, 3. Now with this availability, what can I satisfy? Definitely I can satisfy P0, because P0 needs 8, 4, 3, but here it is 8, 5, 3. Definitely P0 can be satisfied next, right? Therefore we have a safe sequence. This is also called as safe sequence. The sequence in which we can allocate the resources and finish up all the process is called as safe sequence. The safe sequence is P1, P2, P0. Since we have a safe sequence for this state is said to be safe. That is what they have already declared. We need not do it, but just I did it for the sake of explanation, right? Therefore it is safe. right? Now they are saying that from this state, if I get two requests independently, request 1 and request 2, which one do you think operating system will grant it? How can I do it? Then assume that the request is already granted and then check if that state is leading to a safe state or not. If it is not leading to safe state, we are not going to grant it. Now let's check about this request 1. If the request 1 is granted, which means it is asking for P0 is asking for 002. If P0 is asking for 002, then what will be allocation if I allocate it? Then it will become 1 plus 2 is 3, right? And in future it will become 0, isn't it? And now the availability will become 0. Fine. Now if this is the state, so what did I do? I am trying to act as if I have satisfied the request of request 1, and therefore I have allocated the resources required, therefore the future demand will decrease and the availability will decrease. Now we got one more state. Now I want to see whether this state is safe or not. In case if it is not safe, then I will not allocate the resources required by the request 1. I will just pull them out and again restore this state to the earlier safe state. Earlier it was safe, right? I will restore it to that. Let me check it. Now the total availability is 3, 2, 0. Now using 3 to 0, is there anything that I can satisfy? Yes, we can satisfy the need of P1. If I satisfy the need of P1, what will it release? It will release 3 to 0, right? Then it is going to be 640. With 640, can I satisfy P0? I cannot satisfy it. Can I satisfy P2? It turns out that you cannot even satisfy P2 also, because P2 requires 122, right? And this last Z2 is not available, right? Therefore only one request can be satisfied, which is P1, and the request of P0 and P2 cannot be satisfied, and so there is no safe sequence, which means if you go ahead and allocate the resources requested by P0, then you will not be able to ever run the P0 and P2. Only P1 will be able to finish. Therefore it will lead to a deadlock, right? So what should you do? Since it is an unsafe state, right, you are now supposed to not grant this request. So I'm not going to grant the request, I'm going to pull it out. So how can I pull out? Just restoring it back to where it was. So restoring it back to where it was means it is 001, and then it still requires 2, and the availability is 2, right? And the request 1 will not be granted because it is unsafe. It might lead to deadlock. That is why I am not going to grant it. Okay. And now the next one is request 2. Now watch it. So what happens if I want this request 2 is this way. If I allocate the request 2 is P1 has to be allocated 200, which means P1 will get totally 5 here. 3 plus 2 is 5, and therefore the request, this will become down to 1, and then this one will become 1. Got it? Fine. And now the new availability has become 122, and I want to test whether the resulting state is safe or not. Now using 122 as the available, can I satisfy any need there? Yes, one need can be satisfied, which is nothing but P2. If I satisfy P2's need, what will be released? Yes, even P1 can also be satisfied. Let me go with P1 first. P1 can be satisfied because P1 requires 100 and there is 122. Then what will be released? 520 will be released. Then it is going to give us 642 as the total available. Now with 642, can I satisfy P0? No, but then I can satisfy P2 because P2 requires only 122, right? Therefore, I am going to have 211 released. 211 released, right? Then what do I get? I'll get here 8, and I'll get here 5, and I'll get here 3. Now I got 853. Then what is the requirement of P0? 842. Therefore, anyway, P0 can be satisfied here. So even after I grant the request 2, I'm able to get into a safe sequence. I'm able to get a safe sequence, and the state is safe. Therefore, I'll go ahead and grant the R2, which means I'll go into this state. Got it? So request 1 cannot be granted, but request 2 can be granted. That is what is the banker's algorithm, right? So we will act as if we have granted the request and then find out whether the state is safe or not. In case if it is unsafe, we are going to go back. In case if it is state is safe, we are going to give it the resources, right? So in this case, request 1 will never be granted, but request 2 can be granted. Understood this? Okay.